Welcome to This Explainer. Today we've got a really unique opportunity to look under the hood of an incredibly complex system used for brain mapping. What we're going to examine together is the Stage 8 Technical Summary Packet. Basically, it's an external review copy that acts as a meticulous, step-by-step record of exactly how a specific set of brain data was processed. It is rigorous, it is fascinating, and honestly, it's a total masterclass in strict scientific data handling. We're going to take a sort of factory tour of this pipeline, showing us exactly the kind of uncompromising rigor that's required before actual medical science can even begin. To give you a quick roadmap, here's what we'll be looking at today. We'll start with the Stage 8 summary, then look at the strict technical guardrails, move on to affine and nonlinear alignment, check out the Cerebra A Atlas verification, and finally, wrap things up with visual QC and handoff. All right, kicking things off with Section 1. The Stage 8 Summary, which acts as a technical witness document. So, our tour starts right at the core purpose of this packet. It serves solely as a container for documented technical work, rather than any kind of final verdict. Think of it less like a doctor's chart, right? And more like an engineer's inspection log. This document completely subverts our usual expectations of brain mapping. When we think of brain scans, we almost always think of a doctor handing down a diagnosis. But this document emphatically refuses to make any medical diagnosis or interpretation whatsoever. The source text explicitly calls it a technical witness document only. It is literally just here to testify to the math and the measurements, and absolutely nothing else. Moving right along to Section 2, strict technical guardrails. Or, in other words, what this process does not do. Before we even peek at the brain alignment data itself, we really need to understand the incredibly strict safety guardrails the scientists have placed around this entire project. They are remarkably upfront about the limitations of this specific phase. Just look at these guardrail statements pulled directly from the source. No diagnosis, no normality or abnormality claims, no clinical interpretation, no population comparison, and no statistical deviance. Absolutely no claims of identity, destiny, or medical inference are allowed here. The system isn't asking, hey, is this brain healthy? It is simply asking, did we align and measure these 3D pixels accurately according to our tools? Which brings us to Section 3, affine and nonlinear alignment. This is basically our primary assembly line. Here's where the process really starts building sequentially. The pipeline moves from basic template preparation in Stage 8A, which confirms the readiness report, to increasingly complex geometric adjustments. In Stage 8B, we see affine registration. That generally involves scaling, rotating, and translating the brain to fit a model. Then it steps up a gear in Stage 8C with nonlinear registration. That's a much more complex warping process used to precisely match the intricate, unique folds of the brain. Now, before we actually look at the visual proof of these alignments, we should quickly define the term SYN-only. The source notes that these files are specifically designated this way instead of using a generic, nonlinear naming convention. The pipeline is so unbelievably precise that Stage 8C conditionally accepted this nonlinear alignment strictly for planning purposes. This ensures absolute transparency about exactly what type of algorithm was used. Okay, let's put on our QC inspector hats for a second. We can see exactly how Stage 8B achieved conditional acceptance. Take a look at the top right, those checkerboard patterns. That is a classic visual check to see how well the subject's brain aligns with the standardized template. By weaving them together in a checkerboard, reviewers can spot misalignments instantly. They also review mask overlays and left/right orientation checks. This rigorous visual manual review is exactly what allows the data to successfully pass through the Stage 8B gate. Let's step up to Stage 8C and see how this builds. This is the manual nonlinear alignment review. Notice those warp magnitude checks at the bottom left. They look like heat maps. Because nonlinear alignment literally warps the image to fit the template, the scientists have to ensure the image wasn't distorted beyond acceptable natural biological limits. By checking these magnitudes, they can conditionally accept this much more complex nonlinear alignment, passing it safely through the next gate. Next up is Section 4, Cerebra Atlas verification. Welcome to the quality control station. Now, this is a seriously phenomenal detail from the source data. It turns out Stage 8D originally ended with a failure. It initially failed its whole brain atlas acceptance. But the pipeline actually has built-in repair protocols. It immediately triggered Stage 8DR, identifying Cerebral A as the repair target, which prompted a reattempt that successfully verified Cerebral A as the whole brain atlas candidate. I mean, it perfectly shows the resilience and the incredibly strict standards of this process. Side by side here, we can visually confirm this geometric compatibility. On the left, you've got the Cerebra's template overlay, and on the right, you can see the distinct, colorful regions of the Cerebra label coverage. Now, the source packet explicitly adds a caveat here. The Cerebra's provenance remains rooted in a symmetric source, which is MNI 152 NLIN 2009C SIM, even though its grid compatibility with the project's asymmetric target was fully verified. Again, we're seeing total, uncompromising transparency from the pipeline. And this brilliantly illustrates that verification in action. Notice that green outline marking the perimeter of the brain? That's the transformed synstrip mask. Think of it essentially as a digital shrink wrap that isolates the brain tissue. You can see how perfectly it envelops the subject brain data, carefully containing all those distinct cerebralia labels securely within the boundaries of the actual brain. To truly appreciate the massive scale of this pipeline, just look at this raw data output. The system is tracking 1,169,666 total Cerebra Atlas voxels across all the labels. If you're wondering, a voxel is basically a 3D pixel, so well over 1 million individual microscopic data points are being processed and categorized perfectly inside that green mask we just looked at. It's kind of mind-blowing. Out of all those 1.1 million microscopic points, the system ultimately distills the data down to exactly 102 defined Cerebra O regions. The technical QC summary notes that 100 of these regions showed high coverage and only 2 showed partial coverage, with 0 regions showing low or no overlap. That is just a stunning level of precision and distillation. And finally, Section 5, Visual QC and Handoff. We've made it to the shipping dock. Think of this final phase of our factory tour, stages 8F and 8G, as a shipping dock, right? This is where all that visual quality control is finally translated into hard, numeric data tables for external handoff. Here, we do a final visual check. On the right side of your screen, check out the tissue label overlap. The pipeline relies on a tool called Atropos to ensure the transformed subject brain aligns cleanly with specific tissue types. Blue indicates cerebral spinal fluid-like areas, yellow is gray matter-like, and red is white matter-like tissue. They are basically matching their drawn geographic maps against the actual biological terrain. Here we have a manual checklist confirming all of this. Look at all those pass brackets. They manually verified that label IDs align, regional volumes match, mask overlap balance passed for every region, and tissue composition balance passed for every single region. It's just a wall of green lights. Ultimately, after all these vibrant images and complex warps, the final output isn't a medical report at all. It boils down to these 3 highly technical CSV spreadsheets: the regional volume table, the mask overlap table, and the tissue composition table. Pure, unadulterated measurements. For instance, if we zoom in on the regional volume table, you can see it meticulously records absolutely nothing more than the voxel count and technical volume per cerebral A label. No judgments, no normal or abnormal tags, just the raw, verified physical dimensions of the data inside those 102 regions. And to make absolutely sure no one tampers with these final measurements, the entire package is locked down cryptographically. Stage 8G generates the manifest, and Stage 8H secures it all with SHA-256 checksums. The final decision, the external review PDF packet, is complete and ready to export. It finishes its whole journey as a pure, mathematically verified technical witness document. Which leads us to a pretty fascinating cliffhanger. This flawless scientific baton pass leaves us wondering, now that the data is perfectly prepared, flawlessly mapped, and strictly neutral, how will the external reviewers actually apply it? What human discoveries are lying wait in Stage 8I? The foundation has been perfectly laid, but the true interpretation is yet to come. Thanks so much for taking this explainer tour with me, and keep exploring.
Welcome to This Explainer. Today, we're going on a bit of a factory tour, specifically a deep dive into the highly rigorous Brain Stage 8 technical summary packet. If you've ever wondered exactly how raw brain imaging data gets transformed into a perfectly mapped, mathematically precise model, well, you're absolutely in the right place. We aren't looking at medical diagnoses today, no. We're looking at the pure, unadulterated machinery of neurocartography. Think of this as stepping right onto the factory floor, where the raw materials of brain data are assembled into an exact replica. Let's get into it.
Okay, here's our roadmap for the pipeline journey. We're moving chronologically through 5 steps: the strict technical guardrails, mapping, affine and nonlinear, fixing the Cerebrae Atlas, generating technical measurements, and finally, getting ready for external review. Section 1. The strict technical guardrails. Our first stop actually establishes the sterile, objective tone of this entire document by setting some incredibly firm boundaries before a single byte of data is even processed. What's really fascinating here is what this process is expressly forbidden to do. The Stage 8 packet is labeled purely as a technical witness document. That means absolutely no diagnoses or interpretations happen here. No claims about what's normal or abnormal, no population comparisons, no statistical deviance, and literally zero medical inference. You might be wondering, why does that matter? Well, because true scientific rigor requires absolute separation between the technical creation of the map and the later medical interpretation of that map. The pipeline's only job is just to provide objective, perfectly aligned data without a hint of bias.
Section 2. Mapping, affine, and nonlinear.
This is where the heavy lifting actually happens. But to really grasp it, we need to quickly define the term registration. Think of this process like high-stakes cartography, where we have to perfectly align our new subject map against a standardized master template. Imagine trying to take a picture of a brand new city and perfectly overlaying it onto a standard globe. The system has to align the unique individual subject's brain with a perfectly symmetrical master template, just so that apples can be compared to apples later on.
This visual brilliantly illustrates the Stage 8B review, tackling that first major step, affine registration. Just look at the checkerboards and those green outlines proving the initial structural alignment. Now, affine alignment is basically your global scaling, rotating, and translating. It gets the brain into the right neighborhood, making sure the general shape and size fit within the template. That checkerboard pattern is a classic quality control tool. If the template and the subject's brain are aligned properly, the edges of the brain structures will flow seamlessly from the light squares right into the dark squares. Once it passes a manual visual review, it's conditionally accepted, setting the stage for the real magic.
Then, we step up to Stage 8C, where nonlinear alignment introduces some truly incredible precision. While affine alignment gets the general shape right, nonlinear registration, specifically using a tool called SynOnly, acts kind of like digital clay. It tracks warp magnitudes to capture the complex, completely unique folds of the subject's brain. Notice those bright warp magnitude heat maps? You are seeing exactly where the system had to gently push, pull, and stretch the digital model to perfectly match the subject's unique anatomy to the master template. This is the secret sauce that allows for pixel-perfect structural alignment.
Section 3. Fixing the Cerebra Atlas.
Now, science isn't always a straight line, right? And this document is fully transparent about what happens when the pipeline hits a snag. The crucial point to remember here is that a failure is actually a feature of a rigorous scientific method. The pipeline literally failed its whole brain atlas acceptance at Stage 8D. But rather than just pushing flawed data forward, the system worked perfectly to catch the error. It completely halted, pivoted to a different atlas known as the Cerebra Atlas during Stage 8DR, and ran a formal verification. Once the Cerebra Atlas was rigorously checked for geometry compatibility and label validation, Stage 8D reattempt verified it as a successful whole brain candidate. Pretty cool, right?
Visually, we can directly compare the beautiful Cerebra ad template overlay against the subject mask coverage. This proves the scientific fix was a success. The intricate color coding represents the different brain regions mapped out perfectly, while the green outline highlights the subject mask boundary. You can really see how tightly and clearly the Cerebra ad labels conform to the transformed subject brain. It's essentially a visual receipt proving that the pivot to Cerebra wasn't just a quick patch job, it was a precise, scientifically validated repair.
Section 4. Generating technical measurements. Once the atlas is fixed up and verified, it's time to turn all that beautiful visual alignment into hard data. Just to give you an idea of the sheer scale we're dealing with, this pipeline meticulously processed over 1.1 million total Cerebra Atlas voxels. A voxel is basically a 3D pixel. So imagine mapping a landscape by examining 1.1 million tiny microscopic building blocks, ensuring every single one is perfectly accounted for inside the spatial mask. And honestly, it gets even more precise than that. Those 1.1 million voxels were perfectly sorted into exactly 102 distinct Cerebra Agrea regions. Out of all those regions, 100 were marked as high coverage, and absolutely zero, yes, zero, were flagged as low or no overlap technical candidates. I mean, that is a stunning level of mapping fidelity. This tissue overlap plate acts as a visual receipt of that fidelity. It shows exactly how those 102 regions are broken down into technical labels. If you look closely, the blue areas represent cerebrospinal fluid, or CSF-like spaces. The yellow areas indicate gray matter-like tissue, and the red represents white matter-like tissue. The white outlines show you exactly where the Cerebrae Atlas maps onto those specific tissue types. The system is essentially proving that it hasn't just captured the total volume, but has intricately parsed out the exact tissue composition within each microscopic sector. All of that massive visual data, the millions of voxels, the complex tissue segmentations, the nonlinear warps, it's all ultimately distilled into 3 clean CSV spreadsheet files. The first table simply counts the voxels and technical volume for all 102 regions. The second table verifies exactly how much those regions overlap with the overall brain mask. And the third table breaks down the specific tissue composition, so the gray matter, white matter, and CSF, for every single region. It's the ultimate translation from incredibly complex visual geometry into clean, sortable mathematical truth.
Section 5. Ready for external review. Finally, we reach the end of our factory tour and prepare to hand off the final product to the outside world. Stage 8FV gives us this manual table review summary. It's really the ultimate checklist. Every line here passes. All 3 CSVs exist, label IDs perfectly align, regional volumes match, and tissue compositions pass balance checks. The review officially conditionally accepts the measurements, but importantly, it carefully carries forward all technical warnings. Again, total transparency here. It notes things like Z border contacts or the specific MNI symmetry targets, ensuring the researchers who eventually use this data know exactly how it was produced.
Which brings us to Gate 8H, the absolute final step. The system stamps the technical packet as complete. It even generates fresh cryptographic checksums to ensure that not a single byte of this data can be tampered with or corrupted in transit. The final decision is logged, and the packet is entirely ready for export and sharing. The next and final gate is simply drafting the external reviewer directive and handoff letter. The factory floor has successfully done its job. Leaving us with one deeply fascinating final thought. Remember our strict guardrails from the very beginning? No diagnosis, no medical inference. This entire painstaking multi-stage 1.1 million voxel mapping process is strictly just the technical warm-up. So I leave you with this. If this is just the prerequisite to get the map drawn, what kind of incredible medical breakthroughs are waiting for the researchers who are actually allowed to interpret this data? Thanks for joining me on this explainer, and as always, keep questioning the data.
Okay, let's dive right into this explainer and take a factory QA tour of the brain's Stage 8 technical pipeline. This was actually just generated yesterday, on June 22nd, 2026. If you've ever found yourself wondering how raw, messy neurological scans get transformed into perfectly standardized, measurable data well before a doctor ever even looks at them, you are definitely in the right place. We're going to look under the hood of a highly rigid, meticulously documented technical process today. All right, before we even think about looking at any data, we really need to set some ground rules and define the strict boundaries of this document. It is absolutely vital, literally crucial, to separate the technical preparation of the data from the actual clinical interpretation. Think of it kind of like a forensics lab, right? They process the evidence, but they absolutely do not hand down the verdict. That total separation is exactly what ensures the absolute integrity of the final analysis. And that brings us to our core theme today. It's simple. We are inspecting the technical assembly line here. We are not handing down a medical ruling. Every single step we'll look at focuses purely on geometry, alignment, and voxel counting. The system is actually intentionally blind to the patient's actual medical condition just to completely eliminate any technical bias. So, here's our quick roadmap for today. 1. The Stage 8 summary. 2. Strict rules and guardrails. 3. Aligning the brain scans. 4. Applying the Cerebro-Eye Atlas. 5. Visual quality control checks. And finally, 6. Final data and export. Okay, Part 1. The Stage 8 summary, an introduction to the brain's packet. Let's get into it. So the best way to think of this packet is like the ultimate shipping manifest for highly complex neurological data points. It's officially called a witness document. And what that means is, it doesn't make guesses. It simply states the facts. Here's the exact state of the data. Here is exactly how we prepped the templates. And here is how we registered the images. It's basically the bedrock of accountability for the whole system. Moving on to Part 2. Strict rules and guardrails. The factory floor boundaries.
The crucial takeaway here is that this pipeline generates conditionally accepted technical measurements only, zero medical inferences. I mean, just look at that massive list of no's. It almost borders on paranoia, doesn't it? But it's for a very good reason. No normality claims, no population comparisons, absolutely no identity or cognitive inferences. We are purely in the business of saying this voxel is here and that voxel is there. It's honestly a beautiful display of absolute scientific restraint.
All right, part 3, aligning the brain scans, preparing the canvas.
Registration? What is it? Well, registration is essentially like meticulously stretching a totally unique rubber map over a standardized 3D globe. Because, every human brain is beautifully unique, different overall sizes, totally different folds. To actually measure them accurately, we have to gently warp and align the subject's specific scan to a universal standard. That ensures that when we say region A, we're looking at the exact same physical spatial coordinate across every single subject.
You can really see the massive visual difference here between the initial affine alignment and the much more complex nonlinear registration. The affine process, that handles the broad strokes, the scaling, the rotating, the shifting. But the nonlinear process handles the nitty-gritty. It meticulously warps those unique cortical folds to perfectly match the template. It is just a gorgeous two-step dance of sheer precision.
Which brings us to part 4, applying the Cerebra Atlas, labeling the regions.
What's really interesting here is how Stage 8D verified Cerebra A as our whole brain atlas candidate over the specific project grid. There is a highly specific caveat we need to note. The Cerebra A provenance remains symmetric, even though its grid compatibility with the project's asymmetric target was fully verified. And yes, I know, overlaying that onto the TBLMNI 152 NLIN 2009C ASIM target is quite the mouthful. But this intense level of technical transparency is so vital, because downstream researchers need to know exactly what spatial assumptions were baked in.
102. That is the exact number of distinct cerebral area regions mapped and measured in the output tables. The pipeline doesn't just look at the brain as one giant single mass. No, it segments it into 102 highly specific, technically measurable zones, completely ready for detailed volumetric extraction. Let's quickly trace how this builds sequentially, right from the basic template verification in 8A all the way down to candidate table generation in 8F. It's designed as a strict cascading system. If any single stage fails, like 8D actually initially did before a successful reattempt, the whole pipeline just halts. Bam, stops right there. It is a self-checking, highly rigorous progression to ensure absolutely pristine data by the time we finally hit stage 8F. Okay, part 5, visual quality control checks, inspecting the assembly line.
Just look at those bright green synthestrip mask contours, acting kind of like a tight shrink wrap, completely isolating the brain. And balancing that out, the Atropos technical labels ensure the tissue coverage is perfectly mapped. Blue for fluid, yellow for gray matter, and red for white matter. What's happening here is the technician is actively hunting for any spills, any weird gaps, or misalignments to guarantee that these automated boundaries are doing their jobs flawlessly. Now, remember those strict guardrails we talked about? Well, these warnings are meticulously documented precisely because this is a technical measurement only. We had 100 high-coverage candidates and 2 partial coverage candidates noted here. The system is so incredibly sensitive that it literally throws an alert if the data even slightly touches the very edge of the bounding box, those first or last Z-slices. It doesn't mean the data is broken at all. It's just the pipeline fully transparently logging every single minor physical constraint it encountered. Again, leaning right back into that necessary scientific paranoia.
And finally, part 6, final data and export, the shipping manifest.
Seeing that long string of pass notifications is always great. It confirms that the label IDs align perfectly and the regional volumes completely match up. The packet was conditionally accepted, carrying those warnings we just talked about right forward. Basically, it means the voxel volumes make complete mathematical sense. All the mask overlaps are nicely balanced, and the tissue composition is totally statistically sound for every single one of those 102 distinct regions. Over 1.1 million, specifically 1,169,666. That absolutely staggering number represents the total Cerebra A Atlas voxels across all labels, with 1,166,602 of them safely tucked inside the transformed synthstrip mask. Think about that. That means only around 3,000 voxels out of over 1 million fell outside the mask. That is a true testament to the incredible pinpoint precision of the registration process we discussed earlier. Every single one of those million-plus data points has been meticulously accounted for.
And here we are. These 3 simple CSV files represent the hard data output of our entire technical pipeline. We've got the sheer volume counts, the overlap data, and the specific tissue compositions. These tiny spreadsheets hold the whole shebang. It's the heavily refined, completely neutral geometry of the subject scan, and it's all secured with tight digital checksums, so absolutely nobody can tamper with it while it's in transit.
So with the final PDF manifest generated and verified, the packet is at last handed off to Stage 8I for the external reviewer directive. The factory floor has successfully done its job. The pieces are perfectly machined, the strict tolerances are checked, the warnings are all securely logged, and the payload is successfully boxed up and ready to ship. But that leaves us with the ultimate question. With this rigorous, airtight technical packet verified and exported, what will the external reviewers actually discover when the real clinical interpretation finally begins? It really leaves you wondering exactly what kind of stories these millions of meticulously gathered numbers will tell once the doctors finally take over. All of this incredible technical effort, this rigid avoidance of interpretation, it simply sets the stage. The strict science of preparation is officially over, but the complex art of medicine is just about to begin. Thank you so much for joining me on this deep dive through the Brain Stage 8 pipeline today.